Hi, so today I'm going to do some sample problems from chapter 9 as a way to review my own physics knowledge. So let's read the problem first. A shell is shot with an initial velocity of 20 meters per second and an angle of 60 degrees with the horizontal. At the top of the trajectory, which is over here, the shell explodes into two fragments of equal mass. One fragment whose speed immediately after the explosion is 0, so it's talking about the blue thing, falls vertically. How far from the gun does the other fragment land, assuming that the terrain is level and the air jack is negligible? So what the question is asking is, assuming that the orange object keeps following its trajectory, how far is going to be this d? So we can break this problem into two parts, this being part 1 and this being part 2. So to find this part distance, that's just regular kinematics. We can just ignore that because that's really easy. But let's talk about how to find this part. So to find the distance for this part, d equals velocity times time. So we need to find the time that this orange projectile is going to stay in the air and the velocity it has after the explosion. So let's set up a momentum equation for this explosion. So let's set each of the object to be mass m since they are of equal mass, and right before the explosion the momentum, so p equals mv. So the momentum is going to be 2m for the mass times v0x. So v0x is the initial horizontal velocity given by the projectile. And the reason why it's just horizontal velocity is because at the top of the trajectory, there's no vertical up or down velocity, just horizontal. So that's going to be that. And then afterwards, each thing, so the blue one is m times 0, since there's no velocity, plus m. So the orange one is m times v nu, and we don't know what v nu is. So simplifying that, we can take out this part. So looking at this equation, we know that v nu has to equal 2vox. And to solve for v initial horizontal component, you just do v0 cosine theta, which is what do you call it? It's going to be 20 meters per second times cosine 60 degree. So that gives you the velocity. So we have this component checked, and now we need time. So the time is dependent on the height, so height, but to not solve it with height, which you would use 1/2 at squared, I'm just going to use velocity. So looking at the initial scenario, I'm going to write a general form for the vertical component. So that's going to be vi plus at, right? So that's going to be a function of time, and vi is going to be v0 sine theta. And then since g is negative, so minus gt. And then you would just plug in 20 and 60 degrees for these numbers. And then you can solve t really easily by setting this equal to 0. So that's going to be the t that's going to take the projectile from here to here, and also the t that's going to bring it down here. So to find the end distance, change color, final answer, we're going to find part 1 and part 2, like how I drew it here. So part 1 is going to be the time times the first horizontal velocity, which is v0x, and the part 2 is going to be the same time times the new velocity, which is 2v0x, which is, so we can simplify as t equals 3v0x, which if you do the math is going to be 53 meters.